I'm Mary Peters, and this is my Lab 11 Choose Your Own Adventure lab for Physics 2211, Section M02. The main objective of this lab was to investigate and model any system of interest to you in order to demonstrate the tools and methods developed in lab this semester. I chose to examine a head-on collision between unequal masses. I first videotaped a collision between a basketball and a wall, and I then analyzed the video using Tracker and modeled the situation using VPython and the fundamental principles of collisions. The main result was that the initial conditions from Tracker were inserted into VPython, and this included the initial velocity of the ball, the initial positions of the wall and the ball, and the time of the video. VPython was set up to model a collision where the ball bounces straight back from the wall with little change in speed. However, in reality, the final speed of the ball was less than the initial speed. The models relevant to the physical system were the physics related to collisions, including the conservation of momentum. During a collision, the effect of external forces is negligible, and therefore Fnet can be set equal to 0. The momentum principle is that Fnet times delta t equals delta momentum. Therefore, if Fnet is equal to 0, the change in momentum during the collision is also equal to 0. The sum of the final momentums of the two objects is equal to the sum of the initial momentums. The initial momentum of the wall is 0 because the wall is at rest. And the final momentum of the ball is negative the initial momentum because we assume that the speed of the ball does not change significantly during the collision. Therefore, if we plug this into our conservation of momentum formula, we find that the final momentum of the wall is twice the initial momentum of the ball. Here's the video of the basketball hitting the wall. The origin was set at the edge of the wall with the positive x-axis in the left direction. The calibration stick was used to set the diameter of the ball at 0.2304 meters, and this served as the length scale for the entire video. The center of the basketball was tracked at each frame of the video, and you can see that the red diamond represents its position. The initial x position of the ball was at negative 2.201 meters, and the initial velocity in the x direction was found by taking the final x position right before the ball hits the wall and subtracting it from the initial and dividing by the change in time. I then modeled the collision in VPython. The ball represents the basketball and the red box represents the wall. I got the initial ball's position from Tracker and I got the initial velocity, and then I inputted the initial velocity that I just explained to you how I got. And then I took the final time was 0.564 and I put that into the loop, and I told it to find the final position by taking the initial position plus the ball's velocity times delta t. And I modeled the collision aspect by saying that when the ball's position is equal to the wall, then the final ball's velocity would be the negative of the initial velocity. So let's run my code and see the model of the collision. The ball is coming at the wall and then it reflects back with the same speed. Our model assumes that the final velocity of the ball will be negative the initial velocity. However, in reality, according to Tracker, we found the initial velocity of the ball to be 8.74 meters per second, and then I found the final velocity to be negative 5.895, and I found that the same way by taking delta x over delta t after the collision with the wall. So why does our experimental data not match the model? Well, the number one reason is because the velocity was determined during the whole video length, and during that length there were external forces present such as like gravity. And during a collision, we assume that the external forces is equal to 0. Another reason is because it wasn't exactly a head-on collision. The ball was moving in both the x and y directions. Well, thank you for watching, and I hope you've enjoyed my video.